Today I'll be teaching you about aromatics. Aromatics are widely used in products found in your household. This is because they are light and very resistant. Aromatics are helpful in making fibers that match specific needs of products, and they're also able to be produced in large quantities. That's why you can see that aromatics are used in clothing, pharmaceuticals, cosmetics, computers, car and airplane parts as well, also utensils, fabrics, and more, such as furnishing fabrics. Today I'll be going over what they are, the various different types found within aromatics, as well as what they react with and what their nature as a compound is. So first, let's go over what a benzene is. A benzene is 6 carbons linked together in a circle. As you can see on the left, you have 1, 2, 3, 4, 5, 6 carbons linked together in a circle. Within this circle, I've also drawn another circle. This circle represents resonance. Now, resonance is the idea of delocalized electrons being inside of a certain molecule. This means that the molecule cannot be expressed with a single Lewis structure. Resonance represents how in a benzene there are various arrangements of electrons. One thing to consider is that the more resonance there is, the more stable a compound is. This means that benzene, which has resonance, is more stable, hence it is also less reactive. One way you can also draw benzene is just a cyclohexene. But inside the cyclohexene, you'll have 3 double bonds. And this will be a benzene. One thing to take note of is that these double bonds are alternating. As you can see, there's a double bond here. Then there's a single bond, a double bond, single bond, double bond, single bond, and then back to the original double bond. So first, let's go over different types of benzenes. So on the left, the first type of benzene is a toluene. A toluene is a benzene that's also connected to another carbon, or has another carbon coming off of it. As you can see over here, we can see that the benzene is attached to a CH3. This means that it's attached to another carbon that has 3 hydrogens coming off of it. The second one is phenol. Phenol is a benzene that has an OH group coming off of it. As you can see over here, right at the top, we can see that from the benzene, an OH is being bonded to it. Lastly, we have an aniline. Aniline is where benzene is attached to an NH2 group, as you can see over here. So let's move on to naming benzenes. So before learning how to name a benzene, you must also learn how to use the ortho-meta-para naming system. The ortho-meta-para naming system refers to the different kinds of, or the specific placements of substituents on a benzene from the first carbon, which is marked by this X. Ortho means that the substituent placements are from the X to the first carbon next to it. So it could be a 1-2 carbon placement. Meta represents the carbon placements from the X to the M. This means from a 1 to 3 carbon placement. So the substituents are on 1 and 3. Lastly, para represents the carbon placements from 1 till 4, or the P. This means that the substituents are placed on the first carbon and the 4th carbon on a benzene ring. Here's an example of the ortho-meta-para naming system. As you can see on this benzene, we have a bromine attached to the first carbon and the second carbon. According to the rules for ortho-meta-para naming systems, if 2 substituents are placed on the first and second carbon, that means that it follows the ortho name. This means you would write this benzene as O-dibromo benzene. Here's another example. On this benzene, we can see that there's a chlorine atom attached to the first carbon and also the 3rd carbon. According to the rules, if a substituent is on the 1st and 3rd carbon, we can say that this is a meta name. So you would write M-dichloro, because there are 2 carbons, benzene. For our last example of the ortho-meta-para naming system, we have this. This benzene has a fluorine attached to the first carbon and the 4th carbon. Based off of rules, we immediately can determine that this is going to be the P name, or para. So you would write this as P-difluoro, because there are 2 fluorines, benzene. Now, the ortho-meta-para naming system is not the only way to name a benzene. You can also name it as a normal or organic compound using the IUPAC rules. An example is right here. This is a benzene that has an ethyl group coming off the first, second, and fourth carbon. So if you were to write this out, you would write 1, 2, 4 triethyl benzene. Benzenes can also be seen as a substituent within another parent chain. In this example, you can see that the benzene comes off the third carbon. Now, when a benzene is a substituent, it uses a different prefix. So in this case, since it's coming off the third carbon, you'd write 3-phenyl. Phenyl is the prefix given to benzene when it is a substituent of another parent chain. So this compound altogether would be 3-phenyl heptane because there are 7 carbons linked together. If there were multiple benzenes, say for example we had another benzene coming off the 5th carbon, you would write 3,5-diphenyl heptane. Now let's go over the organic reactions that involve benzene. Our first reaction is going to be benzene reacting with Br2. This would normally be an addition reaction because benzene is an alkene, but since benzene has resonance, benzene only undergoes a substitution reaction when reacting with a halogen. The product would be, in this reaction, bromobenzene. To show how similar this is to cyclohexane, which is another alkane, we'll react cyclohexane with Cl2. The product of this reaction is going to be 1-chlorocyclohexane. This shows that both reactions are substitution reactions, and it also shows that benzene reacts like an alkane. Now that concludes me teaching you about aromatics and benzene. To summarize what we learned today, we learned about what a benzene is and what is resonance. We also learned about the 3 substituent groups known as toluene, phenol, and aniline. We talked about the ortho, meta, and para naming systems, as well as how to name a benzene structure. Lastly, we also learned about reactions that a benzene can undergo and how their behavior changes due to resonance. Now that you know all this stuff, and now that I've taught you, here are some questions to test yourself. Look at the handout that's given.